Today, our first topic is energy stored in a capacitor. Let us suppose that we have a capacitor with two plates. One is positively charged and another is negatively charged. Okay, with the help of a charger, okay. Now, suppose at any time the charge on the capacitor is, let us say, Q. Now, because of the charge on the capacitor, it will have a potential V. Now, in order to charge a capacitor, work is to be done against the electrostatic forces. This work done is stored in the field between the plates of a capacitor. Okay, तो जो भी हम काम करते हैं मतलब चार्ज डिपॉजिट करते हैं कैपेसिटर में, ठीक, तो वो स्टोर होता है एज अ पोटेंशियल एनर्जी इन दिस. Now, suppose at any time the charge on the capacitor is Q, due to which potential difference V occurs between two plates of the capacitor. Two plates, let us say plate P1 and plate P2. Now we want to further deposit a charge. Let us say we want to deposit a small amount of charge on the plate of a capacitor. Let us say it is dq. Now, in order to store that charge, work has to be done against the electrostatic forces, because there is already charge there. We have to do the external work to store that further charge dq. Now, if C is the capacity of the capacitor, this capacitor is C is capacity, then you know that Q is equal to CV, or we get potential V is equal to Q by C. Now, since we want to deposit this small amount of charge, small work is to be done. Let us say dW to store that charge. Now dW is equal to V dQ, because we know that work done per unit charge is equal to potential V. Okay. Now, this small work done is stored as a small potential energy, that is dU. Okay. Now, in order to store a charge on this capacitor from 0 to, let us say, Q, then we have to integrate this. Okay. So what we'll get? We will get integral dU is equal to integral V dQ between the charging between 0 to Q. Now this is equal to U, but here we have a variable V and also Q. We will change this into the charge Q. Okay, so we substitute it as 0 is equal to Q. Now from this we have already found that V is equal to Q by C. So we will write it as Q by C dQ. Now the capacity C is constant, can be taken outside the integral, 1 by C. Then we are left with 0 to Q dQ. Now integration of Q is equal to 1 by C q square by 2. Now between the limits 0 to q. So that will be equal to 1 by c, upper limit first, q square by 2 minus 0 square by 2. Or u will be equal to 1 by 2 q square by c. This is the expression for the potential energy stored in the capacitor. We can have other expressions also. We know that q is equal to cv. Substituting in this equation, we get u is equal to 1 by 2, that is c square, v square by c. Substituting for q, cv. So we get c and this will cancel. So u will be equal to 1 by 2 c v square. This is another expression for the energy stored in the capacitor. Also, we can eliminate this c. We know that q is equal to cv, which implies that c is equal to q by v. So here we write capital Q, okay. So substituting here for c equal to, this c is equal to q by v in this equation. So you will get u is equal to 1 by 2 c के बदले में लिखेंगे q c के बदले में q by v, okay, into v square. This comes out to be u is equal to 1 by 2 q by v into v square. This and this will cancel out, so u is equal to 1 by 2 qv. This is another expression. तो एक qv के साथ रिलेट करती है, दूसरी cv के साथ, और तीसरी q और c के साथ. These are three relations which give the energy stored in the capacitor. Okay. If we plot the graph between charge along x-axis and potential along y-axis, then since we know that q is equal to cv, which implies that q is directly proportional to v. Okay. Now if we plot a graph this type, then we will get a straight line. Now let us suppose that this line is OA. We drop a perpendicular B upon this charge axis or x-axis. This is y-axis. Okay. Now what is the area of this triangle? Area of triangle OAB is equal to 1/2 base is OB into altitude. Base is OB and altitude is AB into AB. That is 1 by 2 OB. OB is equal to Q and AB. AB क्योंकि यहाँ से V plot हो रहा है, तो this is equal to V. So this is equal to 1 by 2 QV. So it is same जो हमने geometrical proof के बगैर भी की थी, this relation. ठीक है. तो geometrically the energy stored in the capacitor is geometrically equal to the area of a triangle under the graph VQ graph के अंडर जो ट्रायंगल आता है उसका जो एरिया होता है वो बराबर होता है एनर्जी स्टोर्ड इन द कैपेसिटर. ओके. नेक्स्ट, एनर्जी stored in combination of capacitors. We already know we have two combinations. First, a series combination. ऐसे, let us suppose that we have two, or let us say three capacitors, C1 capacity, C2, C3. नाउ सीरीज जो कैपेसिटर्स होती है उसमें चार्ज जो थ्रू आउट रहता है वो सेम रहता है, इट विल बी क्यू थ्रू आउट। चार्ज इसमें चूंकि यहाँ कोई ब्रांचिंग नहीं। Now energy stored in a combination of capacitors, you know that we have capacitors to combination series and parallels. Let us suppose that we have three capacitors C1 or C2 or C3, or have n capacitors in series. The point here is that charge throughout the capacitors, whether 2, 3 or 4 are connected in series, will remain same because there is no branching. Okay. Now, we know that in a series combination, total capacitance Cs is equal to 1 by C1 plus 1 by C2. Let us say we have N, that is N capacitors 1 by Cn. Now, we know that energy, if since the charge is given Q, so we know that energy stored will be 1 by 2 U, energy will be Q1 by 2 Q square by C. Here we are writing the C as the total combination, total capacitance of this combination. Okay. Now we can write it as 1 by 2 Q square 1 by Cs. Okay. This is equal to 1 by 2 Q square 1 by Cs के बदले में लिखेंगे ये 1 by C1 plus 1 by C2 plus dash 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 plus 1 by Cn. So this will be equal to 1 by 2 multiplying throughout, so will be 1 by 2 Q square by C1 plus 1 by 2 Q square by C2 plus dash plus 1 by 2 Q square by Cn. So this is the energy stored in the first capacitor, this is the energy stored in the second, this is the energy stored in the nth capacitor. So we will get U1 plus U2 plus dash dash plus Un. So this is the total energy stored in the individual capacitor. Sum of the energies, potential energies stored in the individual capacitors is equal to the total potential energy stored in the whole combination, which is sum of the potential energies of the individual capacitors. Now second is parallel combination. Now in parallel combination, what we have, this is a parallel combination. Okay. In parallel combination, what we have the potential which is same throughout. So potential at capacitor C1 it will be V, here it will be V, here it will be V. Here charge does not remain same because of the branching of these. Okay. Now we know that in parallel combination, total combination total capacity is equal to C1 plus C2. If we have n capacitors, so it will be Cn. Okay. Now we know that total energy U, potential energy stored, is equal to 1 by 2 C parallel, यानी सारे का हमने कैपेसिटी V square. Okay. Now so we can write it as U is equal to 1 by 2 V square C parallel. Okay. Now C parallel is sum. Substituting this in here in this equation, so what we'll get, V square C1 plus C2 plus dash 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 plus Cn. Okay. So U will be equal to, multiplying this throughout, so 1 by 2 V square C1 plus 1 by 2 V square C2 plus dash 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 plus 1 by 2 V square Cn. So this is the potential energy stored in the first capacitor, this is the potential energy stored in the second capacitor, this is the potential energy stored in the nth capacitor. So total energy will be U1 plus U2. So total energy U will be equal to the sum of the potential energy stored in the individual capacitors, as was the case in the series capacitance. Okay. Next we have electrostatic potential energy density. Electrostatic energy density in parallel plate capacitor. Definition: energy stored per unit volume in the space between the plates of a parallel plate capacitor. So एनर्जी स्टोर्ड पर यूनिट वॉल्यूम, पूरा जो कैपेसिटर है उसके दरमियान जो वॉल्यूम होता है, ये कैपेसिटर का प्लेट है मिसाल ए, ये बी है, इसके दरमियान जो वॉल्यूम होता है उसमें जो एनर्जी स्टोर होती है पर यूनिट वॉल्यूम, उसको हम एनर्जी डेंसिटी कहते हैं। ठीक, सो एक्चुअली ये इसके दरमियान जो स्पेस होती है उसमें फील्ड होता है। So in other words, we say that energy stored in the electric field between the two plates of a parallel plate capacitor. We know that U is equal to energy stored 1 by 2 CV square. Okay. Now, for a parallel plate capacitor, C is equal to epsilon 0. A is the area of cross section of plates, and D is the distance between the plates. Okay. हम यहाँ पर substitute करेंगे, so we will get U is equal to 1 by 2 epsilon 0 A D into V square. Here V is the potential, not the volume. Okay. Now also we know that electric field E between the plates of the capacitor, E is equal to VD. No, sorry. We know that potential difference V is equal to E into D. What is E? E is the electric field between the two plates of the capacitor. Now substituting here, we get U is equal to 1 by 2 epsilon 0 A by D, and V के बदले में लिखेंगे ED यहाँ पर. So it will be E square D square. 1 D will get cancelled. So U 1 by 2 epsilon 0 A D E square. Okay. Now A is the area, D is the distance. So area into distance, this is the volume V. So we will write U is equal to 1 by 2 epsilon 0 V small v. This is not don't get confused with potential difference. It is small v, that is the volume, to E square. Now we can write it as so we have U is equal to, ये v को हम यहाँ पर लाएंगे डिवाइड बाई v, यहाँ पर बचा 1 by 2 epsilon 0 E square. Now this is U is energy, potential energy stored in the capacitor per volume, because V is the volume per unit volume. So it is energy density UD is equal to 1 by 2 epsilon 0 E square. ठीक है. Now this can be also written as UD is equal to 1 by 2 epsilon 0 E dot E. Okay. Now its units. Now energy density per unit, that is energy per unit volume. Now energy has a unit of joule and volume has a unit of meter cube. So joule per meter cube or joule per meter cube. Now this dimensions important. Okay, energy density UD, इसकी डायमेंशन क्या होती है? एनर्जी के डायमेंशंस होते हैं M1 L2 T minus 2 per unit volume, so divided by L cube. So it will be M1 L minus 1, क्योंकि 3 में से 2 गए तो एक बचा माइनस. ओके, T minus 2. ओके, सो एनर्जी डेंसिटी की ये रिलेशन है. एक्चुअली वी कैन सी दैट दिस इज नॉट, यहाँ पर हमने कैपेसिटर लिया था, तो इट इज जनरल इलेक्ट्रिक दिस एनर्जी डेंसिटी, दैट्स द एनर्जी स्टोर्ड इन द इलेक्ट्रिक फील्ड anywhere or between the plates of a capacitor. Okay,